Hello everybody and welcome to the next page of assignment O. This is on page 150. Looks like we have a proof to do. It says for exercises 1 through 6, let's fill in the blanks. Alright, and here's what we're given. We're told that angle 1 is congruent to angle 5, angle 15 is congruent to angle 5. We're to prove that L is parallel to M and R is parallel to S. Okay, well, let's point out that what we know is congruent. They tell us that angle 1 is congruent to angle 5. They're corresponding angles. And they also tell us that angle 15 is congruent to angle 5 as well. Kind of note that there. So those three angles right there are congruent. They have the exact same measure. First statement, angle 15 is congruent to angle 5. Well, that is, of course, given. First reason is always given. And then they say angle 13 is congruent to angle 15. Well, look at where 13 is. 13 is right across from 15. They're formed from the intersection of two lines. And we know that they are vertical angles. Therefore, vertical angles are congruent. There we go. Now, statement 3 says angle 5 is congruent to angle 13. Well, we're sort of combining the two statements before. 15 is congruent to 5, 13 is congruent to 15. Therefore, 5 would also be congruent to 13. And we do that by the transitive property. Okay, and then we can say that angle or line R is parallel to line S. Why can we say that? One of our postulates, if corresponding angles are congruent, and our corresponding angles, notice how 5 and 13, let's point those out. Here's angle 5 and here's angle 13. They correspond to each other. If they're congruent, then lines are parallel. It's the parallel symbol. Alright, the other statement is given. What haven't we talked about? We have not said angle 1 is congruent to angle 5. That's our other given statement. And they're telling us, given 1 and 5, the reason for the last statement we need to write, if corresponding angles are congruent, then the lines are parallel. Okay, so we want to say our last statement, which is prove line L is parallel to line M, and line R is parallel to line S. There we go. Alright, our last exercise is 7. It says determine whether line PQ is perpendicular to line TQ. Explain why or why not. Well, they're perpendicular if they have opposite reciprocal slopes. So what we need to do is determine the slope of PQ. Let's do that first. PQ, I go down 1 and to the right 2. So for a line PQ, I know that the slope is down 1, right 2. That's a negative 1 over 2. Okay, let's talk about the other line. TQ. Alright, TQ. To go from T to Q, I go up 1, 2, 3, 4, and then I go to the right 2. So for TQ, the slope is positive 4 over 2, and that reduces to 2 over 1. And if you look at these slopes, I got negative 1 over 2 and positive 2 over 1. Those are negative reciprocals, also known as opposite reciprocals. So yes, they are perpendicular. These two lines are perpendicular because the slopes are opposite reciprocal. It's also note that when you multiply the slopes together, you get a negative 1. So we'll prove that right here. Negative 1/2 times positive 2 over 1 does equal negative 1. So yes, we know by that they are perpendicular.